In this video, we look at ethics and ownership. This is 7.1 for the CIE 9618 Computer Science A-Level. So, what are ethics? Ethics concern whether your actions are acceptable according to some set of standards or rules. It differs from morals, because morals are concerned really with personal decisions about right and wrong, whatever you think personally would be the right thing to do or not. However, the two are connected because ethics is often driven by morals. So ethics relate to how actions could impact other people. What would be the harm or potential harm of doing the thing you want to do? That's the question when you're thinking about the ethics. So the ethics are often written down. They're expressed in written policies and codes of conduct. They can be set by the individual company or organization, or by a professional body that oversees many. For example, the British Medical Council for doctors, and they have, for example, on their website, an ethical hub with lots of advice about ethics. For computing professionals, there are bodies like the British Computing Society and the Institute of Electrical and Electronic Engineers. And why is it important that if you're a computing professional, you join a professional body? Well, there are numerous benefits for you, but also for society. As a member, you can get the professional code of conduct that helps you decide whether actions are ethical or not. So if you're not sure whether something is the right thing to do or not, whether it's ethical or not, you can refer to the code of conduct. You can get chartered status, which was recognized, and this is a mark of your competence and professionalism. They offer continuing professional development, so you can do courses and learn more, learn about the latest things. Have guidance on issues like AI and data protection, for example. You can get networking opportunities to meet other people in the same kind of fields, and this includes going to conferences. You can share best practice with people so that everybody's doing a better job. And they can provide support for you in cases like whistleblowing, where you think that your company or parts of it are acting in an unethical way. So what does it mean to act ethically as a software developer? Well, here's a scenario we can look at. A software developer discovers a security flaw in a hospital's patient record system a week before a major deadline. Fixing it properly would delay the release by 2 weeks. Her manager tells her to ship on time and patch it later. So what is the ethical issue and what would you do? So here the ethical issue is conflict between meeting the business deadline and protecting patient data and possibly their safety. So this relates to things like the BCS Code of Conduct, where there are duties for public interest, competence and professional integrity. Often in computing we could be putting many people at risk due to the widespread use of technology. Programs and systems could be used by billions of people, so the risk can be enormous. And I'm sure you can think of software companies that behave in an unethical way and actually knowingly cause harm to people. So in our scenario, what would it look like? If the software developer was acting ethically, they might refuse to ship the software. And the positive results of this could be that patient data is protected, the developer themselves maintain their own professional integrity, the organization could avoid a potential data breach and the cost and legal action associated with that, and prevent their reputation being damaged. It would also potentially build a long-term trust relationship with the hospital as a client, and therefore in the future they may get more work. On the downside, there could be conflict with the management of the company, missing the deadline. There could be financial penalties for late delivery, and it could put a strain on the relationship between the developer and the employer, potentially impacting on their career. If they were to act unethically, though, the patient data could be exposed, breaching confidentiality, potentially causing real harm to them. For example, they could be victims of identity theft and have the medical records tampered with. There could be legal consequences for the company. Breaching the laws like GDPR can lead to fines of up to 4% of global turnover, or £17.5 million in the UK. The company could suffer reputation damage, and the personal professional consequences could be that if the developers traced, they could face disciplinary action, they could lose chartered status, and that could damage their career. In addition, it can cause an erosion of trust in software systems amongst the general public. Now let's have a look at copyright law. Copyright law provides creators of original work, which includes software, protection against the unauthorized use of their work. So if you create something original like a new program, it's protected by copyright, and unauthorized use of that is not allowed. Copyright in many countries is effective as soon as the work is created. You don't need to do anything to be covered by it. And copyright law means that the creator can decide who can use their work and how. So you can put restrictions whilst allowing some people to use it. It's really important to have this in a digital age because it's so easy now to copy and distribute works like software programs at very low cost and very quickly and easily. In the UK, for example, we have a law, it's called the Copyright Designs and Patents Act 1988. It gives creators of original work automatic legal ownership over their own creations and covers things like software, literary works, music, film, art, and so on, databases, website content, and so on. So why do we need copyright? It protects creators' rights and livelihood. Without legal protection, anybody could copy, redistribute, or sell someone else's software without paying the creator, removing the financial incentive to create in the first place. So in other words, if we didn't have copyright, creators would be much less likely to create things, and then we wouldn't have access to them. So we'd be losing out. It encourages innovation and investment. If companies' individuals know that they can be protected, they're more likely to invest more time and money into making things. Therefore, we get better quality products. If it was possible to copy all their work for free, they would not make that investment. It provides a legal recourse. That means that the creators can seek compensation if their work is used without their permission or used in ways that they did not allow, so that they can sue for damages and seek injunctions to stop people from using their work. It allows them to define exactly what is and isn't allowed. So in terms of copying, distributing, adapting, and performing and so on, it allows them to specify exactly what is allowed and what isn't. And it does also allow for some fair use, fair dealing. For example, certain uses within education or for research. And it specifically regulates things in computer science, so the illegal copying and distribution of software, using unlicensed code in commercial products, reverse engineering software, and piracy of digital media are covered. And it does balance the creator's rights with public benefit. In the UK, a typical copyright lasts for the lifetime of the author plus 70 years, so that the work eventually will enter public domain, benefiting society. So the legislation formalizes the balance between the creator and the public. Okay, we have 4 different software licensing approaches here. The first one is Free Software Foundation, and under this, software would be free. You can run it, you can study it, modify it, and redistribute it in any way you want. Okay, the source code though must always be available and the derivatives must stay free. In open source, the source code is public again. Anybody can inspect, modify or redistribute the code. There is a range though of licensing for this. So it could be copyleft, the same as Free Software Foundation, or more permissive licensing that would allow some closed source derivatives. Then there's shareware. Shareware is like a try before you buy approach. So you get the software for free in the beginning. It may be limited in terms of functionality, and you get that for only a limited period of time. The source code is not available, so you can't see it, edit it, and modify it. And then eventually it will convert to a pay model. So if you like the software and you want to continue to use it, or you want more features to be unlocked, then you would have to pay. And finally, we have commercial software. This is software that is being sold for a profit. It has a strict end user licensing agreement. The source code, of course, is not available and you can't see it or edit it. The vendor would provide the support and legal accountability, and it's typically licensed either per device or per user. So one thing you may be asked to do is to choose a type of license for a particular scenario given in the exam. So here's some examples. First of all, a school wants software to teach students how a compiler works and they have a limited budget. So in this case, you'd probably recommend open source or free software. The first thing is, of course, it's free. There's no cost. That fits in with a limited budget. They also mean that source code's available, so the students are able to study and modify the code, play around with it and try to understand it more. Plus, there may be, hopefully, a community that provides support and documentation, rather than coming from a particular company that may just be a public community. However, you may need in-house skill to be able to use this, and there's no dedicated support line. There's no company who's directly responsible for this software, so you don't necessarily have anybody to turn to. And the second scenario is a hospital needing record-keeping software with guaranteed support and legal accountability. And here you would recommend commercial software. Whoever you get the software for, you'll have a contract with them, something called an SLA, which is a service level agreement. That means what they guarantee to provide. And this is critical for a system that has such a potentially impact on safety. It provides legal accountability, so you have a company that you can effectively sue or blame for the problem. And you should get regular updates and security patching from the company. And that may well be written into the SLA where they commit to providing updates. And the trade-off with this, the problem is obviously going to be higher cost. It's certainly not free, and source code can't be inspected or modified, so it may not exactly match your requirements. It may have more or less than you want in it, and you wouldn't be able to do anything about that directly. You can't change the software yourself. And then the third scenario, we've got an individual wants to try photo editing tool before committing to buy it. So they're just looking around, they want to try one for free, and if it's good enough they might want to buy it afterwards. So in this case, shareware. So the free trial lets them try it out and evaluate it, and then the time and feature limited model gives the developer a route to revenue. So the developer benefits from this in that their software can reach a larger audience. Not just the people who definitely want to buy it, but people who just may want to buy it and just try it. So that gives them a chance where otherwise they might have none. And then the trade-off is, if you want to use it on a sort of ongoing basis, long-term basis, you'd have to pay, or if you want more features, then you might have to pay. So the source code is still unavailable in this case because effectively the creator wants to be able to make money from it, so they're not going to give away source code. Now we move on to artificial intelligence. Now there are various kinds of artificial intelligence. Basically, artificial intelligence means mimicking human intelligence. So it's not really intelligent, it's not really human intelligence, it's just a simulation of the sort of things human intelligence can do. So the first one there we look at is narrow or weak AI. This is where we have a system built to do a particular task. For example, facial recognition or spam filters. They just do one thing. They're not able to apply their intelligence to other things. And then general or strong AI would be where we have some kind of human level reasoning across any task. And whilst we think we're sort of getting closer to strong AI, it doesn't really exist yet. And machine learning, this is a subset of AI, so it's a particular type of AI. And this improves its performance over time by learning from data. So rather than having a fixed set of rules, it can adapt and learn and get better. And then expert systems are a type of AI where we basically take human knowledge and then we combine that with an inference engine that can actually generate answers to questions. And all it does is look at the knowledge base it's being given and tries to work out the most likely answer or the best answer based on the information it has in its knowledge base. But again, this is only for a narrow domain. So, for example, it may be very good at being a car mechanic or providing answers about cars and how to fix them, but it can't just switch and do other things. So we have expert systems for things like medical diagnosis, tax and legal advice, mineral prospecting. We use artificial intelligence in virtual assistants. This is called natural language processing. So the ability to understand language is one of the key things that AI has allowed us to do. This is used in things like Siri and chatbots. It's used in autonomous vehicles. So we have the sensor data combined with machine learning. For example, Tesla cars are providing data to learn from all the time. They're recording what they're seeing, what they're doing, all the situations when they're driving around, and that's adding to the knowledge of these systems all the time and used to make better decisions in the future. We have recommendation systems, for example, on Netflix. You get recommendations for what to watch, which uses AI. Fraud detection to try and work out when people are committing fraud. Predicting when things need maintenance. So it's used for things like image and speech recognition in security, biometric security, translation, like language translation, and accessibility tools for those with disabilities. It's also used a lot in robotics, in manufacturing and warehouse automation. So AI's got an awful lot of uses, and there's lots of types of AI, and now we look at the impact that AI has on society and on economies. So some of the benefits, and there are a lot more than are listed here, but improved accessibility is a major benefit of AI. It allows people to interact with systems using things like speech to text. And as we mentioned before, this is useful for people with disabilities who may not be able to use traditional devices. It provides a translation, so you can talk to people anywhere in the world in different languages. You can use systems, read books, and understand situations through this ability to translate language so well. It provides better medical diagnostics and personalized services. So in medicine, for example, AI is being used a lot to do things like detect cancers. Um, Doctors often find it difficult to spot the signs, early signs of diseases like cancer, whereas AI can be trained to actually do a better job at noticing those signals. And personalized services, we looked at things like where it's recommending things on a personal basis, like videos and adverts, so that they're more relevant to people. And of course, there are many more benefits than that. In terms of the economy, uh, one of the main things would be increased productivity and efficiency for businesses. So they can get more done, make more products, increase the profits, and of course, they exist to provide money for their shareholders or for their owners. So this is a benefit to them. It also creates new job categories and shifts some of the more repetitive or less creative jobs away from humans onto computers or robots. So we have new jobs being created like AI engineers and data scientists, and it also enables more people to be able to do things, giving people tools to do new things. Drawbacks, though, in society, uh, artificial intelligence systems do suffer from bias, um, and they can therefore replicate discrimination or even amplify the discrimination. So when we're training artificial intelligence systems, we have to be very careful about how we train them and try to remove any bias. It can also reduce privacy because we actually use AI to analyze people's behaviors and things like um, tracker devices and so on. That we can actually use AI to say predict where somebody's going to be and what they're going to be doing, what they're interested in, what they like, and make inferences based on the data that we have and the artificial intelligence we use. And then in education, one of the problems we have is it can erode critical thinking. So people tend to rely too much on artificial intelligence to provide answers and to generate things. And this means that they don't actually think themselves and therefore don't have the skills that they'll need later. In terms of the economy, some drawbacks are obviously there are some jobs which are no longer required. There may be unemployment in certain sectors. Um, there can be a skills gap between large companies and small companies and rich countries and poorer countries in terms of being able to access and use AI. So it can exaggerate some of the differences that already exist between those groups. We also have environmental impacts from AI, which is a big concern for many people. When we're training the AI models, the large language models, for example, we require a huge amount of power uh, because we're processing so much data. We need huge amounts of training data, and this all needs to be analyzed and processed within the models. They're extremely complex and large models, so it takes a lot of power. And obviously, not all of this power comes from renewable sources, so it has knock-on effects on pollution and the environment as well. Very often, this hardware runs in data centers, large data centers that require cooling, and many of these use water to cool. So the amount of water you need to cool the data centers is quite significant. And then we've got the hardware and e-waste. Now, people are racing at the moment to generate the best, computers, the GPUs and the TPUs, to actually do the training of these models and do the inference that these models require, and replacing those with the latest versions all the time is driving a lot of e-waste. So these the older ones are no longer useful, they tend to get thrown away, and that can cause lots of problems with say landfill or toxic waste and so on, because they're not always the most environmentally friendly things. They're not recyclable or compostable necessarily. However, AI can be used in positive ways. For example, optimizing energy grids for efficiency. So that means deciding what sources of power, what mix of energy production is most efficient and the best. So we're saving energy, uh, burning less fossil fuels, for example, by actually balancing the system and using it intelligently. It's also possible, for example, in Finland recently, they've created a sand battery which heats up sand to store energy when it's cheap, and they're using AI to make that the most efficient approach, so that they're making the most of cheap energy. It's used in climate modeling and forecasting, so we can actually get a better understanding of what's happening and therefore take action that is more effective. It's used in agriculture to be more precise. You may have seen a show we have in the UK, which is called Clarkson's Farm. And on that farm, they're using things like drones to fly over fields, to analyze the fields, and robots to go over the fields, and to see what the land actually needs. So rather than watering or fertilizing an entire field, then they only add fertilizer into the locations that actually need it, therefore saving fertilizer, saving energy, and increasing production as well from the land that you have available. It's used to monitor things like deforestation and wildlife movement and wildlife populations via image recognition. Again, if we can more accurately monitor things, then we can take more effective action. Okay, and that's the end of that section 7.1. It's quite a short section. Next time we'll look at something larger, which is the databases section. Thank you very much.